and the equal method. And we learned how we can use the static method, so with a decorator, and use this on the whole class. Alright, so let's continue, and now let's talk about inheritance. So that's probably the most interesting section in this course. So inheritance is the process by which one class takes on the attributes and methods of another class. So this newly formed class is then called a child class, and the other one is called the parent class. So let's have a look at what this means and how we do this in practice. So let's say we still have our software engineer class. So for now, let's say only pass. And let's say we also have another position, so the designer. And for now, we also only say pass. And now let's say both are positions in a company. So both of them are employees. So let's use a second class, and this is a employee. So this class is more general. So let's say our employee should have a name and an age, and also the software engineer should have a name and an age, and also the designer should have a name and an age. But then later, only our software engineer has this title junior or senior developer and not the designer. So for this, we can use this inheritance, and we say that our employee is the base class or the parent class, and this is a child class that inherits from this class. And we do this with this syntax, so we use parentheses and then put in the base class. And we do the same for our designer. So our designer also inherits from employee. So now both of these classes are also employees. And what this then means is, so first of all, it inherits all of the attributes and functions from the employee. So this will become clearer in a few moments when we do the actual implementation. So we can inherit from this. We can also extend this, and we can override this. So also this will become clearer in a few moments. So first of all, let's talk about inheritance. So let's say our employee now should store some attributes. So for this, as you should know, we implement the init function with self, and it gets the name and the age for now only. So this must be define our function, of course, and then in here we simply store them. So we say self.name and self.age, so equals age. And now we have this, so we only defined the init function in our employee class, but we didn't do anything in the software engineer class. But still, our software engineer now has the name and the age. So let's create a instance se equals software engineer. So let's try to use it like this, because we don't have any init function in here. So, but now it gives us a type error, init missing 2 required positional arguments, name and age. So even though we didn't use an init function in here, it inherits the init function from his parent class, from the employee. So we must use this one, and this takes a name and an age. So we must use name, max, and an age. And now if we run it, then it's working. And then we can also access those attributes, so we can print se.name and se.age. So we see that this is working. And now let's do the same for a designer. So let's create a designer, and this must get a name and an age. So let's use, what did we use before for our designer? Let's say this is Philip and he is 27. And now also for our designer we can print the name and the age. So designer.name and designer.age. So this is working, and now we already see how we can inherit the attributes that we defined only in the base class. And the same is true for instance methods. So let's define a function in our base class, and let's call this work. And then here we simply print and then an f string. And then let's first access the name, self.name, and then let's write is working ... So now both our software engineer and our designer can work. So we can call se.work, and we can call our designer d.work and run this. And then, so let's remove this print statement again. And now if we run it, we see Max is working and Philip is working. So it inherits all the attributes and all the functions here. Alright, so now let's have a look at how. So now we already covered the inheritance. So now let's continue and let's talk about extending and overriding the functionality. So of course our software engineer can also have its own methods and attributes. So first let's start with its own init function. So for this, let's say he also has a name and an age, of course, and he should also get the level and the salary. So what we do then is, since we already have this function in the base function, we don't do the same code in here, self.name equals name and self.age equals age. Instead, we call the initializer of its parent class, and we can do this with the keyword super. So this is referring to its parent class, so to this one, employee, and then we call employee.init, and this gets the name and the age. So now our parent class is initialized correctly, and now we want to store the other parameters that are specific just for our software engineer. So we say self.level equals level and self.salary equals salary. And now, by the way, I realized that each employee should have a salary, so I think this should be better up here. So now also our employee gets a salary, and then we have to pass it to our base initializer, and let's change the order here, salary and then the level. And we only store the level in our software engineer class. So now since we changed that, of course, we also have to change this initializer. So also the designer now needs a salary, so let's say 7,000. And our software engineer also gets a salary, so let's say 6,000. And as level, let's say junior. So now this still works. So if we run the code, we still see Max is working and Philip is working. And now for our software engineer, we can access its level and print this. So now if you print the level, then we see this is junior. But this level attribute now only works for our software engineer and not for a general employee and also not for the designer. So here we see how we extend the functionality, and we also already saw how we override functionality. So since we are using this init function here, we are overriding the init function of its parent class. So now we must always use this initializer and then call the super initializer in here. So this is also something that we must remember if we override the initializer and the initializer of the parent class is doing something else or something different or other, then we must also call the super initializer here so that our object is then initialized correctly. So now everything is working. It has the name, the age, the salary, and the level. So this is how we override it. So now let's extend our child classes some more and give them its own functionality. So let's define a function that is only specific to a software engineer. So let's call this function debug and it gets self. And then here, inside here, we print self.name is debugging. So now our software engineer can debug, and in our designer class, let's extend this class and let's say our designer can draw, and it also gets self, and then we print self.name. Name is drawing. So now our software engineer can debug. So now if we run this, then we see Max is debugging and our designer can draw. So now this is working as well. So now we get Philip is drawing. And we don't have to double print this here, so this should still print the output, yes. And now, for example, to make this more clear, our software engineer cannot draw. So if we try to draw with our software engineer, then it gives us this attribute error. Software engineer object has no attribute draw. So these functions then are only specific to the child class. So this is how we extend the functionality of the base class. And now let's do one more example how we override the function. So we already saw how to override the init function. And now our base class also has the work function. So let's also override this one. So we define the same function in the child class. So for the software engineer and also for the designer. And with this, if we use the same function with the same name again, then we override this. And if we use a new function, then we extend this. So in our employee class, we just print self.name is working. In our software engineer class, let's say self.name is coding. And in our designer class, let's say self.name is designing. And now if we save this and call software engineer.work and designer.work, class, let's say self. Self.name is designing. And now if we save this and call software engineer.work and designer.work, then
designer don't work, doesn't work, doesn't work, doesn't work.
we see that we get Max is coding and Philip is designing. So we have overridden this function, and now since we created a software engineer, it's taken the overridden function from this class and not from the parent class. So yeah, so now we see how we can inherit extend and override functionality. So with this we can get rid of redundant code, and we also get code for free. So we don't have to implement, for example, the init function in the child class, but we still can access designer.age and designer.name. And also for all of them we can access the work function if we don't implement them in here. So if we do it like this and call this software engineer.work, then it's still working. So yeah, and I hope that it's starting to become clear that this is a very powerful concept that you should know about. So yeah, now we learned about inheritance, and now let's talk about one other principle of the object-oriented programming, and this is called polymorphism. And what this means, so this is Greek and means many shapes, and this is closely related to inheritance. So we can write code that works on the superclass, but it will also work with any subclass type as well. So simply put, polymorphism gives us a way to use a class exactly like its parent, but still each child class keeps its own methods as they are. So let me show you an example. So let's say we have a collection of employees, and for now we don't care which type of employee this is. So we have a employees list, and this is a list. And then in here we, for example, we create a software engineer. Then let's create another software engineer. So this is Lisa. She is, let's say, 30, and her salary salary 9,000, and she is a senior. And then we also have this designer in here. So now we have this collection of employees, and we want to treat them just as an employee. So we don't care what's the actual child class right now. So let's say we are somewhere else in our code. So let me scroll down so that we don't see it anymore. So let's say we are in the, for example, we are in the HR department, and we want to motivate our employees. So we write a function, define motivate employees, and this gets a list of employees. But here we don't know what type of employees they are. We simply want to iterate here and say for employee in employees, and then we can call employee.work. So this will work on all employees, but then we get the specific implementation of the child class, so it can take different shapes. So this is what polymorphism means. So now let's call this function motivate employees, and we pass in this list that we created. Then it iterates over each one and prints that the work function. So let me comment this out and this out. So these are the only work calls that we should see. And now let's run this, and then we see this is working, and we get Max is coding, Lisa is coding, and Philip is designing. So yeah, this is the concept of polymorphism. And now let's do a quick recap again of our third section. So what we learned here is we learned about inheritance, and that we can use it with a child class, and this inherits from a base class with this syntax. Then we learned that we can inherit the attributes and functions here. We can also extend attributes and functions, and we can override functionality. And we learned about the super init function. So if we override the init in a child class, then we must be careful and should remember to call the super class of the base class, the super method of the base class. And we learned about the concept of polymorphism. Alright, so now let's continue with section 4, and now let's talk about two more concepts of object-oriented programming, and this is encapsulation and abstraction. So let's first talk about encapsulation. So encapsulation is the mechanism of hiding data information. So this means that useless, and so let's say, but does any that you should know about. So yeah, now we learned about inheritance, and now let's talk about one other principle of the object-oriented programming, and this is called polymorphism. And what this means, so this is Greek and means many shapes, and this is closely related to inheritance. So we can write code that works on the superclass, but it will also work with any subclass type as well. So simply put, polymorphism gives us a way to use a class exactly like its parent, but still each child class keeps its own methods as they are. So let me show you an example. So let's say we have a collection of employees, and for now we don't care. Alright, so now let's continue with section. And now let's talk about two more concepts of object-oriented programming, and this is encapsulation and abstraction. So let's first talk about encapsulation. So encapsulation is the mechanism of hiding of data implementation. So this means that instance variables are kept private and there's only one accessor method from the outside with which we can access or change these instance variables. So with this we restrict the access to public methods, so-called getter and setter methods. And we can also do the same for methods. So instance methods can be kept private so that they should only be used internally and not from the outside. So let's write some code so that this will become clearer. So let's define a class again for our software engineer, and here we again define the init function with double underscores and self, and now again let's say it gets the name and the age, and then we say self.name equals name and self.age equals age. So right now we don't want to set the salary. So let's say the salary should be private, so no one should see this, except later maybe the HR department can access the salary and also set the salary. So for now, let's create an internal variable, an internal attribute, and this should be private. So by convention we use one underscore here and then the name, so self underscore salary, and in the beginning this should be none. And then let's also use another private attribute, and let's call this the number of bugs solved. So this will be useful later for an internal function, and in the beginning this is 0. So right now these can be accessed from the outside, but these should be kept private. So if we now, let's create a object again, a instance se equals software engineer, and the name is Max and the age is, let's say, 25. So we can print se.age and we can print se.name. So let's run this. And now we shouldn't access the salary from the outside. So technically in Python this is not completely private. So for example we can access the self.salary. So if we initialize this with 5,000 and save this and run this, comma, then technically this is working, so we can access this from the outside, but we shouldn't. So for each attribute or function with an underscore, this should be kept internal. So if we want to make it really private, then we could use a double leading underscore, and now if we try to access this, then this will not work. So this will raise an attribute error because from the outside it doesn't see this variable here because we use this private syntax. But yeah, in practice you almost never see this, but you see one leading underscore in practice a lot. So yeah, so as I said, technically you can access this, but you shouldn't access this from the outside. And yeah, so right now we have public variables or attributes and private attributes. And now these are only used internal, but now let's say our HR department needs a way to access those variables. So we can say we define a public function get salary, and here we simply return this. So we return self._salary. So again, here we are inside of this class. So this means we should be able to access this. And then also from the outside, our HR department should be able to set the salary. So we define a function set salary, and this gets self, and then it gets a value. And now here we set this, so we say self.salary equals value. And now let's change this to none in the beginning. And then from the outside, what we do here is we say se.set salary, let's say 6,000, and then se.get salary, and print this. Then this should print 6,000. And here I made a beginner mistake, so I said we should always remember to put in self, and now I forgot it myself. So yeah, put in self and run this again. So yeah, so now it's working. So we see we get 6,000 here. So now we should be able to access and modify it from the outside. But these two functions, so-called getters and setters, this should be the only way from the outside to access this internal self._salary attribute. So why is this useful? Why should we apply such a concept with this encapsulation and this private attribute? So for example, what we could do here is when we set the salary, we could do some more stuff. For example, we can check the value if this is actually a valid salary. We can also enforce some constraints. So we can be funny here and say if the value, first let's check it. If it's smaller than 1,000, then let's say no, this shouldn't be possible. Then let's still say self.salary equals 1,000. And if we accidentally put in more here, if our value is greater than 20,000, then let's also restrict it. Let's say this shouldn't be possible. Then this should be 20,000 and not more. So we can do checks, we can enforce constraints, or we can of course do other stuff. For example, we can check if the bank information is still valid. So yeah, that's why the scatter and setter can be useful. And now let's also show you how we can apply this concept for a private function. So let's give it first, let's give our software engineer the code function first again with self, and then in here what we want to do, we want to increase the number of bugs solved. So we say self.numBugsSolved plus equals 1. So now it should be clear that there there's no need to access this variable from the outside. The only place where this is relevant is when we do work with our software engineer. So when he is coding, then he is also solving bugs. So this is the only place where this will be increased. And so yeah, so this is one more internal thing. And now let's say when we set the salary, we only want to set a base salary from the HR department, because the HR department is not so familiar with the work the software engineer is doing. So they are only setting a base value of the salary, and then inside here we calculate this. So based on how productive our software engineer was, so for this let's write a internal function, and now this also gets a leading underscore, and let's call this define underscore calculate salary, and this gets self, and this should get the base value here. And then we check if self dot underscore num bug solved is smaller than 10, then we simply return the base value. If self dot num bug solved is smaller than 100, then we apply a factor, so we return base value times 2, so he gets double the salary. And otherwise, if he even solved more than 100 bucks, then we say we return base value times 3. And now in here, so let's get rid of those constraints, so we don't want them right now. So let's say our self.salary equals self.underscore calculate base, calculate salary with the base value. So now this is how we do this. And now again, we only want to do this internally. There's no way, there's no need from the outside to call this. The only thing we want to call from the outside is then set salary and get salary. So now let's say we have a software engineer, and let's say he is being very productive. So let's say for I in range, and then let's say let's only use 70 right now. And then we call se.code. So he is coding 70 times. This means that our number of bugs solved should be 70. So for now we can do a quick check. So we can say print se dot, and as I said, we can access those private parameters. This is just for demonstration that this works. So yeah, but we shouldn't do this. But we see this is 70, and now we set a base salary, and now if we print the base salary, so then it should be in this if case, and it should apply the factor 2. So now if we get this, then we should get 12,000 actually. So let's run this and see if this is working.
Всем спасибо за стрим, всем пока.